Hey everyone, and welcome. Today, we're going to demystify some of the most essential services in Amazon Web Services. But instead of just listing them, we're going to frame this as a journey. The journey of building a modern, resilient application right from scratch, using all the core building blocks that AWS gives you. So let's get started and lay that first foundation stone.
Look, we're not going to get lost in the academic weeds here. The goal is to give you a really solid practical guide to the services you'll actually need. This is all about knowing what matters for building apps that can scale, stay secure, and are ready for whatever the real world throws at them.
So here's our game plan for today. We'll start with the absolute basics, compute and storage. From there, we'll build out our own private network, figure out how to lock down access, and then get ready for success by learning how to handle big traffic spikes. After that, we'll dive into modern databases and messaging, and we'll wrap it all up by making sure our app is fast for users anywhere on the planet.
Every single application, I don't care what it does, needs two fundamental things to even exist: a place to run its code, that's compute, and a place to store its data, that's storage. In the world of AWS, this whole journey really begins with a service called EC2, or Elastic Compute Cloud.
So, when you launch a virtual server, you're actually making two big decisions. First up is the instance type. Think of this as your virtual hardware. How many CPUs do you need, how much memory, and so on. Then you choose an Amazon Machine Image, or AMI. That's your software blueprint, the operating system, maybe some pre-installed packages, basically everything you need to hit the ground running.
All right, so how do you pay for all this? Well, you've got options that let you balance cost against flexibility. On-demand is pure pay-as-you-go. Perfect for when you're just testing things out. Reserved instances are for your steady, predictable workloads. You commit for a year or 3 and you get a massive discount. And then there's spot instances. That's the real gamble. You bid on spare AWS capacity for huge savings, but, and this is a big but, your server can be taken away with just a 2-minute warning. It's the definition of high-risk, high-reward computing.
Okay, so our server is running, but where does it keep its data? You've got two main choices here. Elastic Block Store, or EBS, is like your persistent virtual hard drive. Your data is safe and sound, even if the server shuts down. Instance Store, on the other hand, is temporary. It's incredibly fast, because it's physically attached to the machine, but if that instance stops, poof, your data's gone. The rule of thumb is simple. If you can't afford to lose the data, you absolutely have to use EBS.
But what about all the data that isn't tied to one specific server? For that, we have the legendary S3, the simple storage service. You should think of S3 as a basically limitless digital warehouse. You can throw anything in there: backups, website images and videos, even massive data lakes for analytics. It is truly one of the foundational pillars of the entire cloud.
Now, the real genius of S3 is how it helps you manage cost. You don't just pay one flat rate. Instead, you pick a storage class based on how often you need to access your data. And the trade-off couldn't be simpler. The less you pay to store your data, the longer you have to wait to get it back. You can even set up rules to automatically move older data to cheaper, colder storage, saving you a ton of money without you having to lift a finger.
So, we have our servers and our object storage. Great. Now we need to put them somewhere. We can't just leave them out in the open. We need a secure, isolated network in the cloud that we're in complete control of. And that brings us to the Virtual Private Cloud, or VPC. A VPC is, well, it's pretty much exactly what it sounds like. It's your very own private, isolated little section of the AWS cloud. It's like building a digital fence around your resources, creating a secure network that is completely separate from every other AWS customer. This is the private playground where all your instances get to live.
Now, inside this private network, security groups act as the bouncers for each and every server. They're basically virtual firewalls with two key rules you have to remember. First, they're stateful, which means if you let a request in, they automatically let the answer go back out. And second, and this is the most important part, they default to deny. Nothing gets through that door unless you've explicitly put its name on the guest list.
Okay, we've secured our network, we've got bouncers at the doors of our servers, but there's an even bigger question looming. Who is allowed to manage all of these resources? Who can actually create, delete, or change things in our AWS account? This is where identity and access management, or IAM, becomes absolutely critical.
IAM really boils down to 4 main building blocks. You've got users, for individual people or maybe an application. Then you have groups, which are just collections of users to make life easier. Then you have roles. These are special identities with temporary credentials that can be assumed by a user or even by another AWS service. And finally, you have policies.
These are the rulebooks, the JSON documents that spell out in black and white what is allowed and what is denied.
And look, if you remember one thing, one single thing about IAM, please make it this. It is the golden rule, and it will save you so much time when you're troubleshooting. It does not matter how many allowed permissions you have. If there is a single explicit deny statement anywhere, access is denied. End of story. Full stop.
Okay, let's take a breath. Our application is built, it's secure, it's running, but now we get to face a really good problem to have: success. What happens when our app gets popular and traffic starts to explode? We have to be able to scale.
I mean, this is the question every developer dreams of having to answer, right? But that dream can turn into a nightmare really, really fast if a sudden flood of users brings your single server to its knees. So how does AWS help us handle the crowds without just, buying a bunch of servers and wasting money?
The first part of the answer is the Elastic Load Balancer, or ELB. And honestly, that smart traffic cop analogy is perfect. It sits right in front of all your EC2 instances and intelligently spreads out all the incoming requests among them. If one of your servers happens to fail, the ELB is smart enough to stop sending traffic its way, which keeps your application online and available. A load balancer is great, but what happens when all of our servers are busy? Well, that's where auto-scaling comes in and creates this beautiful automated loop. A monitoring service sees the load getting high, which triggers a policy that automatically launches a brand new server. Then the load balancer sees this new server and adds it to the group. The magic is, this works in reverse too. When traffic dies down, it scales back in, shutting down servers you don't need so you're only ever paying for what you're actually using.
So, our app is now this scalable, resilient machine. But modern applications have complex data needs, right? It goes way beyond just storing files. They need specialized databases, and they need really robust ways for different parts of the system to talk to each other.
When it comes to your core data, you're really looking at two main paths. On one side, you've got RDS, the Relational Database Service. You'd choose this when your data has a nice, predictable structure and you need to run complex queries. Think financial data or an e-commerce store. On the other side is DynamoDB, a NoSQL database that is built for pure speed and massive scale. You want this when your data structure might change and you just need ridiculously fast reads and writes for, say, a web-scale app.
Now, how do different parts of our app communicate? Well, instead of having them call each other directly, we can use messaging services to decouple them. SQS is a message queue. It's a reliable buffer. One service can just drop a message into the queue, and another service can pick it up and process it whenever it's ready. SNS is different. It's a publish-subscribe service. You publish one message to a topic, and it gets fanned out to many, many different subscribers all at once. We're on the final step. We are in the home stretch. Our application is architected beautifully. But now we have to solve the very first problem of global delivery. How do users even find our application? This is the job of DNS, which is basically the internet's giant address book. In AWS, DNS is handled by Route 53. But let me tell you, it is so much more than a simple phone book. Think of it more like an intelligent global switchboard for all your traffic. You can set up rules to send users to the server that's geographically closest to them. You can route them based on their location, or you can even automatically fail over to a backup site if your primary one goes dark. It really is DNS with superpowers. So there we have it. We've journeyed all the way from a single virtual server to a secure, scalable, globally routable application. We've touched on compute, storage, networking, security, and scaling. These are the absolute core building blocks, but AWS is always changing. So the final thought I'll leave you with is this. When you look at what you do at your own field, which one of these building blocks holds the most potential for real, game-changing innovation right now? Thanks so much for watching.